là la!
Hi everyone and welcome back to another National 4 Maths lesson, and in today's lesson we are going to be talking about trigonometry. We will be carrying on from our lesson on Pythagoras as we expand our knowledge on right-angled triangles and how we can use this thing called trigonometry ratios in order to solve more complex problems involving right-angled triangles. And we'll look at these problems as we get near to the end once we have an understanding of what this thing called trigonometry actually is. So going back to our lesson on Pythagoras, which I'll link down below, we learned that this side that's opposite the right angle in a right angled triangle can be called this funny thing called the hypotenuse. And back then we said that these two sides don't really have a name, but today we're going to change that, because if we have an angle and we know an angle within a right angled triangle, we know the value of it, then we can assign a name to each of the other two sides as well in a right angled triangle. So let's say we have a problem where we have a right angled triangle and we know this angle in here, which we've just called x degrees at the moment. Then what we can do, we can label this side of the triangle the opposite. It's called the opposite because it lies opposite that of the angle that we know. In this case it lies opposite of x degrees. And this side down the bottom, we call this one the adjacent. And the word adjacent just means next to. So what that refers to is it's next to the right angle and this angle of x degrees. The side next to both of these angles is called the adjacent. So to summarise how we label each side of the right angled triangle, the hypotenuse is the side opposite the right angle, as we can see. The opposite side is the side opposite the other known angle, as we can see here. And the adjacent is the side next to both the right angle and the known angle, like so. And the reason that I said the known angle is because obviously we have an angle in here as well, but this might be unknown in the question. Normally we only have a right angle and a known angle, an angle that we know the value of. So in that case, that's why we call the opposite the side opposite the known angle. Okay, so we're going to do a little exercise on practicing labelling the sides of a right angled triangle. So the first thing to do is identify where the right angle is, which we can see here, and the known angle, which is indicated down here. So the first thing we know that the hypotenuse always lies opposite the right angle. So we can see the right angle here, the side that lies opposite is this one here, therefore that must be the hypotenuse. And now we know the opposite is the opposite side of the known angle. So here's the known angle and this is the opposite side, therefore this side up here must be the opposite. And finally we have the adjacent, which is the side that lies next to both the known angle and the right angle, so that must be this side in here, which we can label like so. And the reason that I've just included these abbreviations is because when we go to solve problems using the names of these sides, it's just easier to shorten it to the first three letters. So for opposite we write OPP, the hypotenuse we write HYP, and the adjacent we write ADJ. So in our lesson on Pythagoras, we learned that for a right angled triangle, if we know the lengths of two sides within that triangle, we can use Pythagoras to calculate the length of the other one. So let's say for example we know the length of this one and the length of this one. We can use Pythagoras' theorem to calculate the hypotenuse. But we can also use this thing called trigonometry ratios if we want to calculate, for instance, the size of an angle within a right angled triangle if we know, let's say, any two sides. But we can also use trigonometry ratios to calculate the length of a side if we only know one other side and the value of an angle. And when we talk about trigonometry ratios, there are three ones that we need to know, and they are called the sine ratio, the cosine ratio, and the tangent ratio. And this is just the shortened versions again when we go to solve problems. So the sine is just shortened to SIN, the cosine is shortened to COS or cos, and the tangent is TAN or tan. Now you might ask, what are these ratios though? What do they mean? And really all three of them do, is relate the lengths of each of the sides of a right angled triangle to the ratio of each of them, and also the angle that we have And all we really need to know at the moment is that each three of these things are just functions that help us solve for either 1, the side of a triangle, or 2, the angle within a right angled triangle. So the best way to illustrate this is for me to write out what each of these functions are. And I'm going to write it out in the shortened forms that I've included. So beginning with the sine function, what we can say is the sine of an angle, which is x degrees, is equal to the opposite side in a right angled triangle divided by the hypotenuse. So basically what that is saying is, if we know the length of the opposite within a triangle and we also know the length of the hypotenuse, the ratio between the two, or in other words the opposite divided by the hypotenuse, gives us this function called the sine of x degrees, and this is just the angle. So I'll label that as well just for clarity. So in here, this angle can be called x degrees. And then the cos function, it looks similar, so we can say the cos of x degrees is equal to, and this time the ratio is the adjacent side over the hypotenuse. So here we have the adjacent, so the length of the adjacent divided by the length of the hypotenuse gives us the value of the cos function to the angle. And then finally we have the tangent function, so we can write for short, and the tan of the angle x degrees is equal to, and this time it's the opposite side over the adjacent side. So that is our three main trigonometry ratios. So what we have here is basically three equations, and each of them in different ways relates the sides of a right angled triangle, so the opposite, the hypotenuse and the adjacent, to the angle within the triangle. And the way they're different is because each of the functions are different, so the sine, the cos and the tan functions are all different. And all we need to know in the moment is that these functions can be used on our calculators, so we don't need to know any of the background stuff that we'll get into in future lessons. But essentially, when we want to calculate the length or an angle within a right angled triangle, each of these functions are pre-programmed into our calculators. So looking at this example of a scientific calculator, we can see here that we have the three buttons that indicate each of these three functions. So there we have the sine function, the cosine function and the tangent function. And when we go to solve problems, it's these three buttons that we use to pick whichever function that we are working with. So these are the three trig ratios that we need to know to solve problems related to right angled triangles. And the way that we can remember them is by this abbreviation called SOHCAHTOA. And what this thing SOHCAHTOA refers to is the beginning letter is each of our functions, sine, cos and tan, and the last two are the sides of the right angled triangle that we are working with. So our first one here, SO, stands for the sine of x degrees is equal to the opposite over the hypotenuse. Then we have cosine, which is equal to the adjacent over the hypotenuse, and the tan is equal to the opposite over the adjacent. So if you can remember this thing called SOHCAHTOA, then we can easily remember each of these three relationships. So that might have seemed a little bit complicated and a little bit hard to get your head around at first, but it's probably best to understand trigonometry and trig ratios by doing examples so we can see how it works in action. So here we have an example where we're being asked to find the length of side x, and we've been given a right angled triangle with an angle of 51 degrees in here and a length of 22 centimeters on this side. So the first thing that we want to do is to label each of the sides of the right angled triangle. So here we have the hypotenuse, which is opposite the right angle. Here we have the opposite side, which lies opposite the known angle of 51 degrees. And down here we have the adjacent, which lies next to the angle and the right angle. Once we've done that, our next job is to figure out which one of the three ratios that we have to use in order to solve this problem. Is it going to be the sine function, the cosine, or the tangent? And the way we do this is by looking at each of the sides again and thinking, what side do we know and what side do we want to find out? Well, looking at this problem, we know the value of the hypotenuse because we're giving a length of 22 centimeters, and we want to figure out the adjacent x. And once we've done this, we then look at each of the three functions that we want to have, each of the three ratios, and we figure out which one has the adjacent and the hypotenuse. And looking at that, we can see it's this one here, because we have the adjacent, it's the second one, and the hypotenuse, which is the third one. And because that's the case, that means we look at now the first letter of the SOHCAHTOA, and we think now that's going to be the cosine function that we use. So to write that out, our cosine function of x degrees, which is the angle, is equal to the adjacent side over the hypotenuse. And now the next step is we put the values in from our problem into this equation. So I'm going to write it out, and we can say that the cosine of our angle, x degrees, and in this case our angle is 51 degrees, so I'm going to write that in as 51, and that is equal to the adjacent over the hypotenuse. And the adjacent is the side we want to figure out, so that's going to be x over the hypotenuse, which is the given value, the given length of 22 centimetres. And now, since we want to solve for x, we can use a bit of algebra in order to rearrange this equation. So what do? We have to take this value of 22 centimetres over to the other side, and it's currently being divided. So what do? When we change the side, we change the sign, and if something's been divided, we then multiply it when we move it over to the other side. So this is going to look like the cos of 51 degrees multiplied by 22 centimetres is equal to x. And now all we have to do now to solve x is put this into our calculator. So we use the cost button on our calculator, we type in 51, we close the brackets, and then we multiply this by 22, and then from this we get a value of around 13.8 centimetres for our length x. So these 5 steps are how we use to solve the last problem, and they can be used for any sort of trig problem similar to this. So the first step that we did was we labelled the sides of the triangle, identifying the hypotenuse, the opposite and the adjacent. We then, based on this, chose which ratio we wanted to use, either the sine for SO, the cosine for CA, or the tangent for TOA. And after this, we then put our known values such as the length or an angle into the equation, and then depending on what we wanted to solve for, either the length or angle, we rearrange this equation, and then finally what we have left, we can put this into the calculator and that will give us our answer. So let's look at another problem so we can use this 5-step approach to solve it. So here we're asked to calculate the length of x, and we've been given a right angled triangle with an angle of 67 degrees and a length of 5 metres here. So the first step, we have to identify which of these 3 sides is the hypotenuse, the adjacent and the opposite. So here we have the hypotenuse as it's opposite the right angle. This side is the opposite because it's opposite the known angle, and here we have the adjacent next to both the right angle and the known angle. Our next step is to figure out which of the 3 ratios that we have to use. So what do? We look at the problem and figure out which length we have and which one we want to find out. So we have the adjacent here of 5 metres, and we're asked to find out the opposite x. So we have to look at these 3 here, and we figure out it's going to be the tangent, because here we have the opposite and the adjacent, so this is the equation that we're going to be using for this problem. So using our TOA equation, we can then say that the tan of the angle x degrees is equal to the opposite over the adjacent. So we can then write this out as the tan of our angle, which in this case it's 67 degrees, is equal to the opposite side, which is x, over the adjacent side, which is 5 metres. And the next step we have to do is then rearrange this equation for what we want to solve, and in this case we want to solve for x, so we have to bring this 5, it's being divided on this side, so when we change the sign, we change the sign, so then it's going to be multiplied by 5 by this tan of 67 degrees. So we can say that x is equal to 5 multiplied by the tan of 67 degrees, and then all we have to do now is put this into our calculator, and this gives us a value of roughly 11.8 metres for the length of x. So let's recap this first lesson on trigonometry. We've said that in a right angled triangle, the hypotenuse is the side opposite the right angle. The opposite side is the side opposite the other known angle, and the adjacent side is next to both the right angle and the known angle. We now know that we can use this thing called trigonometry ratios to solve problems related to right angles. We can use them to calculate an angle if we know the length of two sides, or we can also calculate the length of one side if we know one angle and one side. We now know that these are the three trigonometry ratios that we use to relate the angles within a right angled triangle to the lengths of the sides. So we have the sine of an angle is equal to the opposite side over the hypotenuse, the cosine of an angle is equal to the adjacent over the hypotenuse, and the tan of the angle is equal to the opposite over the adjacent side. And the way that we can remember which one of these to use is by this abbreviation SOHCAHTOA, where we have the last two letters and each of them represents the sides of the right angled triangle. In our next trigonometry video, we are going to go over a few more examples and we're going to explain some of the concepts discussed in this video in more detail. If this video has been helpful to you, make sure and drop us a like, and if you have any questions, make sure you comment down below. And if you'd like to learn more about our services and to help you with the National 4 curriculum, head over to penguin-learning.com. Once again, thanks a lot for watching, and I'll see you in the next video.